Hello and welcome to yet another exciting video. In order to change this byte from 11 hex to 12 hex, we need to be able to calculate the checksum, otherwise it'll have a checksum error and it won't use it. And in order to calculate, we know it's a cyclic redundancy check because changing one bit caused a large change in the checksum. So we need to go and reverse engineer that. So what I've done is I've essentially broken it out into a flat file. I've gone in the checksum, I put it at the end, so it's just one giant long string. So I've got one with the 0x in front of it, and it just keeps on going and going and going. So the checksum's all the way at the end now, where it normally would be for the programs that I'm going to use. And if we go all the way back here, same with this. This is the same stuff, same data, it just doesn't have the 0x's in there to designate hex. And what we're going to do is run the command line here. And let's go ahead and make that big. Hard to type one-handed, but we'll make it happen. We're going to reverse engineer the checksum using the reverse engineering checksum program here. And so this is just to bring it up, we need to tell it the width, which is, we know it's a 16-bit checksum, cyclic redundancy check, and we want to tell it S to search for the algorithm, and then we're going to give it some data. So let's do width of 16 and dash S to search for it. And then what we need to do is grab, it needs some data. It needs at least a couple packets. And so it takes this as a flat file like this. We're going to copy that. We're going to go back, and you can't do Control V, but you can come in here and do paste. So that's one instance, and it expects to checksum at the end, so that's what we did. And we're going to go grab the other file here. Make sure we're at the beginning. Oops, did I get it all? Nope. There you go. I'm going to copy that, and we're going to go back and paste it in as well. And so now it's got two instances with varying data, and that should be enough. We hit enter, and it calculates our checksum, calculates our CRC16 as being the X modem standard. So if you watch the Nissan Leaf BMS, where I did the same thing to calculate the checksum in that, they rolled their own, so it was a completely non-standard one. This one, they've decided to actually use, it's a standard, so polynomial is 1021, and it happens to be called X modem. So what we can do is we can verify it by going to the old Sunshine 2K CRC calculator JavaScript page here, and we'll just go grab our, so this one takes it with, we need the little hex symbols on there. So we're going to copy the whole thing. We'll go to the web page. We're going to tell it we're doing a CRC16, and if we scroll to the bottom here, we find X modem. So we're going to select that, and you can see it set the polynomial to 1021. We're going to erase this and paste in our bytes, and our checksum is 95 FE. We don't want to include that because that's what we want to calculate. So remember, 95 FE, boom, 95 FE. So we know that that one's correct. We can try the other one. Was that the one I just copied? Nope. So we'll go back and we'll grab this one as a test. Copy that, go back to the web page, and we'll delete out our the one that we put in here already, paste in the new one, and this checksum is 24/7A. So remember 247A, get rid of that, 247A. So we've confirmed the checksum, and we now are ready to go modify that byte and calculate a new checksum and put it back. And for hardware, I'm thinking about using my little motion controller and just do a little bit of SPI with it and have it read out the flash memory chip, modify that byte, calculate a new checksum, and then write it back. And that'll be next episode. Thanks for watching.